All right, we are back with the ThinkSystem SR630v4 here again. This video is going to be all about cooling, and that's really it. Cooling benefits, some metrics on this system. Specifically, some of the cooling that we're going to be talking about can go not just to this system, but to other systems as well, and just in general. So that being said, let's just go ahead and jump right into it. Now, I guess before we really get into it, one thing that I want you to remember is performance equals power equals heat. The industry right now is trending towards performance. Everyone wants something more performant, faster, better than it was before. And with that, that equals more power and it equals more heat. So with that, we've got to find new ways to actually cool systems, because all that heat and power in a small system like this just doesn't really work. So there's quite a few options for this server specifically. There's a standard heat sink as a cooling option. This is going to be for pretty low end systems, not really needed here. What we see here is going to be the performance heatsink. Let me just go ahead and take a look, zoom in here. To give you a refresher on the previous video talking about server components, cold air is being pulled in the front of the server by these fans blowing across the components, and hot air is out of the rear of the server. These T-shaped heat sinks here are going to be the high performance heat sinks, and that's covering the CPUs, which are going to be the hottest component in this server. So maximizing the cold air that's flowing across these T's here to really cool those CPUs is going to be necessary to make sure that those CPUs are performing. Now if we take a look at closed loop is just exactly what it sounds like. There is a loop here that is closed, so water and ethylene glycol is the liquid that's flowing through here. It's a system very similar to your car. The liquid flows through the radiator. It's cooled by the fans. It flows across the processors and heats back up before going back into the radiator to make sure that this system is staying cool. Now with this setup, it's going to be a little bit different configuration because the system itself actually takes up a decent amount of space, but other than that, everything is really the same. You don't have to have any piping or anything out of the rear of the server. You could add this. You could get a new server configured with this, and it would be almost the exact same as your previous servers. All the maintenance can still be done, by you or the Lenovo technician, depending on what needs to be replaced or whatever. The savings rate, the why behind this. Keeping the processors cooler is going to be a benefit, of course, because of processor performance, but fan power savings is another thing to look at. And with this is going to be about 56% fan power savings on a server level. And then if all of these were in a rack, we're going to see about 5% rack level power savings. These are numbers, put together by Lenovo through their internal testing. So I'll give you some more of those as we go through. Going to the open loop for processors, this is going to be the first step into actual, water cooling. And there's going to be, a coolant distribution unit somewhere in the data center that's actually pumping the water through the servers. And it's just doing CPU only, so just the core of the system. And, that's very effective because that is the hottest part of the system itself. So you can see, we've got our processor cold plates. We've still got the fans in the system to cool the rest of the components. We've got a tray for leak detection as well, which can send alerts to the system owners. With this open loop processor cooling, we've got recorded about 74% fan power savings, and then at the rack level we're going to see about 26% rack level power savings. So a big jump from the closed loop Still going to be, less than a completely liquid cooled system, but again, a benefit of, still keeping this same system that you've been using for a long time or you're very familiar with, keeping that 1U system, that 1U footprint, compact data center, and getting a lot of power savings from this. Now, the open loop complex compute. This is going to be the next step up. It's going to include cooling voltage regulators along with thermal pads next to the DIMMs. Same setup, same system, still having water being pumped through a CDU across the system. Zooming in, hopefully that wasn't too fast. You can see the only thing that I want to point out is these are going to take, a little bit different configuring. Here you can see we've got fewer DIMMs than we had in the past. So we've got to have those thermal pads in between the DIMMs. So there's going to be less DIMMs in this system. But other than that, it's still going to be about the same as what we just saw before. With this system, we're going to see about 84% fan power savings. And at the rack level, we're going to see about 33% rack level power savings. So very significant savings when you're looking at an entire data center or an entire rack worth of servers. We can also just, quickly look through these diagrams as it's flowing, the liquid flowing across the actual components and through the piping. If this is something that you are interested in, you can find all this information and this 3D tour on lenovopress.com in the 3D tour or in the product guide. If you liked this video, let me know in the comments below. Leave a like, leave a comment. Again, if you want to go through all this information yourself, there's going to be links in the description. That being said, thanks for watching, and till the next time. Bye.